All right, we will not wait for the other students, and let's start our today's lectures. Last lectures, we have installed the IntelliJ and JDK, and we have run our first program. And for this class, we are no longer only for this class, we will not use, you will not require to use the IntelliJ, but just following me is fine. So for today's class, we will begin to get more knowledge about the programs. This is for the last week, so we will skip it. Well, okay, this is the end of the last week. We have get some output from our program, and then today we are going to analyze the whole process, how to from the creating the programs and get the result. Here is the shortcut of the program, and for the main page, here is the how it works with the JDK. First, we create and modify our source code, and then that is the welcome.java file. And then we save it to the disk, and that is the source code there. And then when we are using the command line to compile our source code, the first command we use is javac, and the space come with the welcome.java file. And using this command, the JDK will compile our source code into bytecode. This is the format of the bytecode. That is method welcome and the 0 load something and something else. And this file is the .class file. If you can remember that last time, once we using the javac welcome.java command, and there will be a .class file will automatically generated, and that is the bytecode file, which is this one. After we got the bytecode, and then the second command we used using the command line to get the result is the Java welcome without extension. This is the way we run the bytecode. No C after the Java and no extension after the welcome. After we run this command, and then we will get a result. That is, your terminal will output the string that you wrote into the double quote, welcome to Java. And for this slide, you should always remember the javac comes with a full name of the file with extension. However, when you run the bytecode, only Java welcome without extension and without the C after the Java. And then I will introduce something about the JDK. I'm not sure whether you will be, I'm not sure whether the certificate exam will touch with it, but better you need to remember this framework. Like JDK includes the JRE and development tools. And the JRE means the JVM plus the library set. If you don't understand, it's fine currently, but try to memorize such a thing. Once you have done with this course at the end of this semester, I think you will have a concept, a notion of this framework. And then I will briefly introduce some more details of these slides to you. The JDK that you installed in your computer last week is a software development kit that it is used to build the Java applications, and it contains the JRE and a set of development tools. With some old versions of JDK, the JRE and the development tools are separate, but for some later versions and the most recent versions, they combine them together. as a JDK, only one file. So you only need to install one time and then you get everything. And there is a note that JDK is for development. It is no need for running the existing Java programs, and JIE is enough. That means that if you have, let's get back to these slides. If you already have your code and you only, the welcome.java, this file, we say if you already have the source file code, you only need JDK to run it, to compile it into the bytecode, and then you run the bytecode and you get the result. This is what JIE do. However, if you want to debug your program, like I want to know what's wrong with my program, only JIE is not enough. You need the development tools. You need Java compilers, debuggers, and something else. And that is some descriptions of the whole workflow that we just mentioned. And there is another thing that for the execution, the JVM, that is the left round, execute the bytecode, translating it to native instructions. And corresponding to this chart, JVM will works in this place, compile source code, javac welcome.java. And here is for the JIE. JIE provides an environment to run the Java programs, but doesn't include development tools. Just as I mentioned that if you already have the source code and you want to run the program, JIE is enough. However, if you want to debug or you want to make some optimizations with some more advanced tools, you need the Java compilers, something. So in this case, you need both of these two square, the yellow square state. And JIE is intended for end users who only need to execute applications, who are not going to revise or make any modifications. And it provides all the runtime requirements for Java applications, and it doesn't support compilation or debugging. And that is the difference between JIE and JDK. And this is another thing you should memorize. In case in the certification program, you have to, there might be some multiple choice. Okay, and then let's review the whole process. And when you have the welcome.java, this is the java.file source, Java source file, and then it will be compiled by a Java compiler, and then generate the .class file, welcome.class. This is called Java bytecode executable file. And this Java.class file will be executed by the JVM with some other library code. After this JVM, and then you will get your output. Currently, you may not still feeling confused, but try to memorize it. And there is another thing, different things with Python is that Python, they don't need the compiler and they don't generate .class file. For Python program, they only need an interpreter just directly from the Java source file, and then you get all the output you need. And they don't have the Java compiler, they don't have the bytecode executable files, and they don't need some Python VM. They don't need. What Python need is just an interpreter. It is their difference. But currently, you don't need to remember what is Java doing. Just remember this workflow for Java. And then let's trace a program. For all the animation slides in our coursework, I included a link in our website. And you can use it for more. sorry. Okay. You can use that visualizations more user-friendly. And here is the link. Contents. Program animation. And if you clicked in, and you will get all the, this is from Colorado State University, but it is also used by the Brooklyn College. And the author gave us a lot of animations for trace the program. For example, for this one, let's see, this is almost the same thing with the code we wrote last time. So let's start the animation. Okay, here for the first line is public class welcome. We define a Java program. We name it a Java class. And the second line, this program, it would indicate everything that in detail to about what this line of code is doing. The second line, the animation says that the program starts the execution from the main method, and the main is here. And if you click the next, and they will tell you that the statement displays welcome to Java to the console. And there is an example of the pictures of the console. And in the future lectures, all the animation things, you can find it through the link in our module session of the program animation, and you can try it directly from your end. Sometimes the slides version is not so user-friendly. Then I will go back to the slides. Oh, sorry. Okay, we just trace a program execution, and we will explain the whole program in detail in the later sections. And that's it. Well, we will start off the anatomy of a Javagram. And for a Java program, all of them will include a class name, a main method, some statements and statement terminators, and there will be some reserved words, and there might be some comments there and blocks. And then after that, I will introduce them one by one directly. First, for the class name, every Java program must have at least one class. That is, in our previous example, is the welcome.java class file, right? And in that file, we create a new class in the IntelliJ IDE, and then we name it welcome. And after we name it, we press the enter, the IntelliJ IDE will generate a welcome class for us automatically. And that is the class name, welcome. And you should remember that the class name is always be the same as the file name. And then I will demo. You don't need to open your IntelliJ. Just follow me, it's fine. Okay, please give me some time to launch my IntelliJ. Okay. Where is mine? Okay, here. Here for this program, as we can see, this is the java.file, welcome.java. And this is our class name. What if I change it to, like, I change it to Sunday? And then you will find that there is a red curly line underneath the whole first line. And here it will indicate some problems. I hope you can see. It will indicate in the problems output file, they say that class Sunday is public, should be declared in a file named sunday.java. And the IDE will throw out a warning or an error to you. So that is what we say, the class name should always be consistent with the file name. So let me change it back to welcome. And then the error is automatically be removed. Slides. Okay, then let me introduce the main method to you. For the second line, in the first lectures, I told you input something like PSVM. This is the shortcut to generate the code in IntelliJ. It stands for the public static void main, and a bracket inside is a string args. And you have to memorize the whole line of this thing, because it is a very fixed writing of the main method. I mean, all the main methods are writing like this, no exceptions. This is in order to run a class, and the class must contain a main method named main. And this is the start of the whole program. And in our trace, and you will see, if you go to the animation online there, it will tell you that this is the entrance for the whole program. And we can also say that enter a main method. And then a statement. A statement represents an action or a sequence of actions. And in our example, the statement system output print line and welcome to Java in these programs is a statement to display a greetings. However, we will have some other statements in our future works. And in Java, all the statements will be terminated by a semicolon. If you have get involved with Python, and you will know that Python, they don't have the end terminators, but they will use the indent to indicate a line of something. But in our Java, the format, I mean the indent, is not sensitive for the whole program. And then I will give a demo for you. Here we have 4 lines, and this is the indent, right? What if I delete them? Everything starts from the start, right? Can I still get the correct output? And we can try. And then it is built. Okay, then see, the correct output is still there. That means the indent is not sensitive in the Java. And there is an easy way for us to format it. That is, let me see. If you click the refactor, there's supposed to be a format tools. Code. for reformat code. Let's see. Yeah. And then, okay, let me, in case you want to find, let me record this one. This here, you should go to IntelliJ, go to the code tab, and then there is a reformat code, and the shortcut is Control plus Alt plus L, and then your code will be automatically formatted with the correct format. All right, I will end this demo. And in Java, we have some reserved words. And reserved words, we know that we name it as keywords. They have a specific meanings to the compilers and cannot be used for other purpose. For example, when the compiler sees the word class and it understands that the word after class is a name for the class. That is public class. These are reserved words. And welcome, it is we human give the program's name. It is a given name of the program. And the same thing is public static void, also main. Actually, the first line, except for the string and args, they are almostly the reserved word. And there's supposed to be a number of reserved words you'd better to remember. And I will release those reserved words after these lectures. I find it in the W3 schools, but I didn't include it in this slide. And let me introduce the blocks. In our program, each pair of the braces, I used to name it like curly braces, in a program forms a block that groups a component of a program. In this example, the outer braces, we name it a class block. And yeah, in the inner braces, starting from the second line to the last second, here public static void main to here. This is a method block. That means it contains a method. For the outer line, that means its whole body, it contains a class. And there are some special symbols like opening and closing braces, parentheses, and brackets, double slash, double quote, and semicolons. Those are special symbols, and this better you cannot use in the class names, only in the program content. Here, I will introduce the dots, and this prints the Java. This is the same thing we have been included. This is the, okay, let's review. This is the class block. Inside it is a method block. Both of them are included in the braces. And here, this is the parentheses. What the parentheses do is include some meaningful things. Here we say parentheses is used with method. And here, this is the comment symbols. And there is another one. Let me show you in the IntelliJ. If you want to comment something like I want to make some notes, right? Here, I use double slash, make comments. I write, this is the class name. And then all the things after the double slash, include the double slash, will not be executed by the JDK. And let's try. And then it only prints this thing. And for the double slash, it doesn't affect the output and it doesn't throw an error or a warning. However, there is another method to make comments that we say that is a block comment. We start with a single slash and a star and end with a star with a slash. All the things between will be commented. That means will also not count into the program. Like this is a demo from DAT 47. And let's try. And both of these two things, they don't affect the behavior of this program. And usually we use these comments to make notes to our programs when we are self-study or even when you are in the companies using the comments to denote something meaningful to the program. So some other programmers or your colleagues will understand, oh, what is this mean? Then let's get back to the slides. Here is the single quote. Single quote will, everything between the single quote, we say that is a string. If we use double quote, that means the things in the double quote will be consistent, to the output without change. And we can say that it is a sentence supposed to be output. And I will introduce some programming styles and the documentations. Here for the appropriate comments, I just made some comments in our codes. And for some other scenarios, like we can include a summary at the beginning of the program to explain what the program does, its key features, and its supporting data structures and any unique techniques it uses. Currently, we will not write such a thing, but maybe in the future, if you get into work and your company will require you to do such a thing, and they will have a fixed format for record the informations included in the program. And apart from the informations, and you can include your name, class sessions, like I have done, that denotes that this program is for the DAT 47. And there are some naming conventions. Usually, if you are not using the reserved words like public, static, something, and you can, that the words can be used for naming. However, there are some naming conventions in programming Java programs, like you have to choose a meaningful and a descriptive names. For class names, it is usually, but I recommend that each time you should capitalize the first letter of each word in the name. That compute expressions, for the compute, it is an individual word, and you capitalize the C. For expressions, it's another English word, and you capital the first E. And for proper indentations and spacings, as I showed you that Java is not indentations sensitive. However, you'd better to do that because that will make your code to read easily. And for the spacings, try to use blank lines to separate segments of the code. And some of the programmers, they prefer to using the tab. Also, tab sometimes create blank lines, but it will depend on the company's policies, whether it is allowed. As in some softwares, they cannot recognize the tab, and they can only recognize the space. And there are two styles of writing Java code. The first one is the next line style. As you can see, the next line style means that the curly braces always starts from the second line. It is not the way we write in the IntelliJ IDEA. IntelliJ use the second one, that is end of line style. Both of them are correct. If you see two examples, if you see one example of the next line style in your exams, if he asks you whether it is correct, you should select that it is correct, because the style doesn't affect the program's behavior. And usually in C and C++ programs, some of the companies prefer next line style, but in Java, most of the companies prefer the end of line style. And then we'll introduce some programming errors. The first is syntax errors, which is detected by the compiler, and there is a runtime errors caused by the program to abort. And there is some logic errors, produce incorrect results. And let's see this one, syntax errors. This is the public class showed syntax errors, and this code has a syntax errors. Well, what is the syntax errors? What should it output? I mean, what it will output with such errors? Then let's try to program it in the IntelliJ IDEA. You don't need to code, and just watch the videos. Watch me to code is fine. I will demo. Then we are back to the IntelliJ. Here we will new a class name. Here. Here we will new Java class. This is the class name. Remember, always capitalize the first characters of the words. Show syntax errors. The SSE should be capitalized. And once we enter the class name, and then it will automatically generate a class frame for us. As you can see, this is a public class. And for the curly braces, we call it a class block. And in a class block, we should include some method, right? So here we use the main method, that is PSVM. Sorry, PSVM should be the lower capitalized. And then we say, I will copy the syntax errors from the slides here. Okay, at this moment, as you can see, it will indicate some errors right here. It means line end not allowed in string literals. That means something is wrong, right? Since semicolon is the termination, however, the double quote is not doubled, right? We only have the left double quote, and then we should include the end of the double quote. After that, you will see the syntax is corrected by including one more double quote. And here, the program will be run correctly. And that is the syntax errors. That means something the compiler can detect before we run the program. Then we'll back to the slides. And the next, okay, here it has some explanations that there is a missing keyword. Oh, sorry. because I use the PSVM and it will automatically generate the void for me. And here in the examples in the slides, it should be included PSV. V stands for the void. PSVM. And then the second syntax errors is the double quote here. Okay, let's go to the next errors. For the runtime errors, let's see what is these errors. Public class show runtime errors. The first line is correct, right? And for the second one, PSVM. Public static void main, it's still correct. String args, right? And then we use SOUT, that means system output print line. And 1 divides 0, 1 over 0. Seems also correct, right? But we don't have the double quote. It's fine. But what is the error? Let's try in the IntelliJ. Then here we will include another Java class that is show runtime errors. And I will copy the code from the slides rather than generated by the IntelliJ. Otherwise, it will indicate everything correct. Okay, here. Let's see. There is something wrong in the first line. Maybe not, but it indicates. And then public static void main. Okay, let me change it to another line. So what is the problem? Let's see the log. As you see, okay, show runtime errors. It says that the class is public, should be declared in a file named show runtime errors.java. And the second, this is a warning. Not numeric overflow in expressions. The second one, it indicates that, it's divisible by 0. Usually we don't do that, right? Because we all know you cannot always put 0 under to be a divisor. But what if we do? And then, is this the things that create the errors? Okay, let's correct it, okay? Like we don't divide by 0. Let's see if we divide by 1. Okay, cannot be replaced with 1. Okay, how about 2? Okay, 2 is fine. Then the warning has been removed. And then the class show runtime errors. What is the problem? Actually, I don't know. But let me try to rename it. Rename the file. It's quite weird. Okay, I still don't know where is the problem, but now it has been correct. Because it says, according to the previous error log, that it indicates something. That means it indicates some inconsistency between my file name and the class name. So I use the class name to replace the file name. Now it has been correct. So let's run the program. And then it is 0. Why it is 0? Okay, fine. We will discuss it later. But now the runtime errors has been corrected. So let's get back to the slides. Here, for the runtime errors, it indicates that the integer 1 cannot be divided by 0. The statement causes a runtime error. That means when you execute it, it will throw out some unexpected things. And if you're using the IntelliJ, it will automatically generate a error message. And there are another error. We name it logic errors. All right, let's have a look over the program. For this program, the first line seems correct, right? Public class something. The second line, PSDM, is still correct. And the system output. Okay, so in the first two lines, it doesn't use the ln. It is correct in Java because the print, if you're only using the print, the code will not automatically generate a new line. That means the single quote, the content in the single quote will be concatenate with the second string automatically without changing a new line. However, this one, it will. How about let's code it in the IntelliJ? Here we will generate a new class name. Show logic errors. Okay, we will use the format. Okay, format code now. It seems everything fine, okay, all right? So it says 9/5 star that is multiplied by 35 can be replaced with 35. Okay, it's just a warning. It's not an error. So that means this code can run. We can run it. Let's try. And the output is Celsius 35 is Fahrenheit 67. So is there anything wrong with this statement? I mean, is this reasonable? Like Celsius 35 is Fahrenheit 67. Here, as you can see, if you're using only print, everything will contact it together. 35 is, and will, after that, it is the Fahrenheit thing. And then is the output for the calculation. Only after this print line with the ln, it will generate a new line here. That means change a line. But what is the problem with this code?
Nothing. I think it just wants you to be simple, I guess. It tells you that you're wrong.
Yeah. P is lowercase. Okay, sorry, I didn't saw the chat. Okay, actually I'm not good at converting the Fahrenheit, but let's using the Google. The entire.
Oh, it's wrong.
No. I'm open the Google Chrome. It's okay. But I didn't find my. Oh, here. Wait. Celsius to Fahrenheit. And that is 35. Okay. So in Google, the 35 Celsius is equal to Fahrenheit 95. And the equation is performed like 35 multiplied by 9/5 plus 32, right? And then let's get back to the program. Here. It looks something incorrect, right? 9/5. It seems that this is correct, but why it is not 95? It's okay. And I will tell you that why. It is because this is a double it is not an integer. It is a float point. It's a float point thing. That means the 0.59/5 is one something, right? The one something, the something is discarded by the program. So that's why it generates 67. It is incorrect. However, this code can run. We can run it, right? And there is a difference. And now we can conclude that there is a difference for the syntax errors here. Let me remove the quote. If you didn't correct all the syntax errors, you cannot run. Let me run it. See? That means if you didn't debug it, when you try to run, it will generate the error message unclosing string literals. And only when you fix each box and you can run. And for the runtime errors, it's the same thing. Therefore, the runtime errors, it is initially doesn't have the void, and it is the 0. And before you run the, okay, I have to, okay. For this one, you cannot even click it because it is not runnable, right? And only when you correct this one, and then you can run the code. However, for the logic errors, you can run. It can run successfully. The only thing is the output is not correct. That's the difference. And you can try. I will upload the code to the module sections. I will create a module, and you can download it or you can write it by yourself on your local machine. And then I will get back to the slides. And then I will introduce something else. And for the Java, we using a statement like import something. Here we say it is explicit import that we use a star to denote I will import everything from this package. However, this is explicit import. That means after the java.util.something, I use the specific package name here to import, but there is no performance difference. And we can try in our code. In Java, there are a lot of packages this is the built-in packages there. Not only the Java util, and there are some others, and we will touch it in the later chapters. But currently, we only demo the utils package. Week 1. Okay, I will demo it in this file. Import. The first line denotes implicit import. The second one is explicit. They are the same. And this is the way you import the packages. You always start from import this word and import some packages. This is star, means you import the whole utils package. And this means that you only import the J option pane. However, it seems that in my local files, I don't have such a package as cannot reserve. I don't know why. It means maybe the JDK is not compatible, but it's fine. But for some other utilities, let's see. Like I can import some streams. This is the explicit import. I will correct the slides. so that you will not mislead it by the slides. Okay, fine. And that's it. But identifier or star expected. Oh, that means it is not the end. It means the stream still contains something. All right, that's it. But I will record it to the slides. I will find a specific correct packages for you. Currently, I don't know because I have to search. But I will give you the correct thing. I will update the correct slides for you after the lectures. Okay. I will mark it. I guess it's because this code is coming from a pretty old version of JDK. That's why, but it's fine. And what you have to know is that the star means implicit import. Without star, it is an explicit import. And then let's go to next slide. And we will get some easy things. And let me introduce what is a computer. And a computer consists of a lot of components, like we say the CPU, the memory, and hard disk, storage device, input, output device, and all the things are connected by a bus. That is how they communicate to each other. That memory sends data through bus to the CPU, and the CPU gets some output, like calculate the 1/2 or 1/0. Although it is not allowed in the true programs, sometimes it will generate the infinite number, infinite. And then no matter what it generates, the output will be wrapped into a data container and then conveys through the bus and get back to the memory or to the output devices or input devices. That's the way they communicate. And for the CPU, the full name of CPU is Central Processing Unit, and it is the brain of a computer. It retrieves the instructions from memory and executes them. And the CPU speed is measured in gigahertz, with 1 gigahertz is equivalent 1 billion cycle seconds. And this will be detailed introduced in your computer architecture course in the future when you maybe go to the high senior year, like the 3rd year or 4th year. If you select such a course, computer architectures and computer systems, you will get involved a lot with such a thing. And this is the memory. The memory is to store data and program instructions for CPU to execute. And it is all an ordered sequence of bytes. Each holds 8 bytes, usually 8 bytes. But for some super computers, they may be longer. And if you buy a PC today, it might have 8 gigabytes of memory. For mine, I have 32 gigabytes of memory. And I will show you my specifications of computers to you. Later, I introduce everything. Okay, it seems that everything has introduced. Oh, and then I will show you where to check your configurations, like the CPU and the memory. In my laptop, I think it's in the settings, and I go to systems. Storage. This is the storage, not the memory. Or let me check with the PC properties. Actually, oh yeah, here. And then as you can see, there is installed RAM. We say RAM is the memory. If after course, you can check with your own computer. Usually, I think in today's computers, it's usually supposed to be 16 for the, oh yes, thank you. It is supposed to be 16, but for some, I mean, more expensive laptops, it will use the 32 gigabytes. We say the RAM, also, we say the memory is equal to the RAM. They are the same thing. And for the CPUs, it seems that here it doesn't show the CPU. Oh, here it's 2.30 gigahertz. This is my CPU specification, and this is the full set. And you can check your own after the course. All right, and then let's get back to the slides. And this introduced the data is stored in a big array. We say the memory content. This is the memory that we say the 32 or 16 gigabytes in our computer. Usually, in the memory, they will give the memory, all the memories, the address 2000 and 2001. It is same thing with our address. And this is the memory content in a block in the address. It's such like, this is a house, right? This is your house number or street number, your address there. The 01000101 there. This is the content. That means the people living in this house. And it is the encoding for character J. We will introduce it later in the later chapters, but just you have a notion of how data is stored is enough at this moment. And for storage devices like disk, CD, and tape, in our computers, it is the disk. Let me show you. Last time in the office hours, I saw many people only have one disk in their laptop. I suggest that you have more. This is storage, the C, D, E, F, and you can split it into 4 or 8 as you wish, or you can combine them together into one. I saw some students only using one. If you are only using one in Windows, that will cause some problematic, as if your laptop has some problems, all the files in the C disk. I mean, if you reinstall your computer, and all the contents will be discarded and renewed. So it's better for you to try to go to YouTube and or go to some store, ask them, or you can do it by yourself to split some more disks, so that if you have some computer, your laptop is problematic and you have to install the systems, and it will not affect the things outside the C disk. For me, all the documents I stored in the F disk. So that means even someday my computer got problematic and I have to install, I can retrieve both the files there without modification. Just a suggestion. And then this is the storage in our computer. And the output devices, like the monitor, printer, they are all the output devices. And this is some general introductions about the resolutions and the dot pitch. And the screen resolution specifies the number of pixels in horizontal and vertical dimensions of the display devices. Like pixels, short for picture elements, are tiny dots that are formed an image on the screen. A common resolution for a 16-inch screen, for example, is 1024 pixels wide and 768 pixels high. The resolution can be set manually. I think everybody can try to reset the resolutions in your own laptop to have a notion of what it is. It is pretty easy. Just change the display settings is enough, and then you can restore it back quickly. Well, I will not show because I'm afraid that if I show that, there might be some problems and then I have to reboot my computer. I'm sorry for that. For the dot pitch, and this is the amount of space between pixels measured in millimeters. The smaller the dot pitch, the sharper the display. If you are going to do a master's or to do PhDs, for currently there are some research like the computer visions. They have a lot of things dealing with the resolutions and dot pitch. It's a promising directions of research. But you are too young to get in touch with that. It's okay. Just have a notion of that. And the communication devices. A regular mode use a phone line can transfer data in a speed up to some blah blah blah. And this is you just need to know the communication is a modem and the NIC. For example, if I turn off the modem in my house and I will lose connection with you, that means I will not have the Wi-Fi. Or if you turn off the data or hotspot in your phone, that means your phone cannot calling to others and you cannot use the data. That means this is the communication has been cut off by yourself. And those things are all communication devices. And programs. All right. It's very straightforward. Computer programs are also known as software, are instructions to the computers. Why it is instructions? Currently, we only learned one instructions. That is the SOAT. Is the systems out print line or system out print. This is instructions to output a message to the console or to the terminal. This is only the one instructions we get in touch, but we will learn more instructions, or you can say the statements to the computer. And such a thing means that you tell a computer what to do through programs. Without programs, a computer is an empty machine. Well, yeah. Computers don't understand human languages, so you need to use a computer language to communicate with them. Maybe in the future, if you choose the computer systems and the computer architectures or programming languages, and you may require to write a compiler or interpreter. In that course, well, you will get involved with a lot of computer instructions. I don't like those courses. It's too hardcore. But better to take it in undergraduate courses, because if you master something like that, you will be very competitive in the job market. And the programming languages, there are a lot of types. There are 3 types. The first is machine languages. We say the bytecode 101010. It is because the computers only can recognize 2 things. One is 1, the other one is 0. It is a set of primitive instructions built into every computer. The instructions are in the form of the binary code. What is the binary code? That is the binary, only 2 things, 1 and 0. That is the machine language. So in the future, if the problems ask you to identify what is a binary, what is a machine language, and you should select the things that only with 1 and 0. And the program with native machine languages is a tedious process. And moreover, the programs are highly difficult to read and modify because only 1 0, 1 0. You don't, for us humans, we cannot understand without translation using compilers or something because it's not straightforward, only 2 different things. So, and their combinations is complex. We don't understand it, but the computers can understand it. Okay, it's fine. It's enough. And another thing is assembly language. Like here, add 2, 3 result. That means if in the future you are writing a compiler, you will get in touch with that. That means you should add, this is an instruction. You should add 2 and 3 together. 2 plus 3, and you will get 5, right? And the 5 will write into the result. This is a variable, or currently we take it as a container to store the data. And the result is 5. This is assembly source file, and this is assembly source instructions. And they were developed to make programming easy because the computer cannot understand assembly code. However, a program called assembler is used to convert assembly language programs into the machine code. Here, this is assembler, that if you write such a thing, the assembler will convert it into 1010, the machine code, and then the computers can recognize it. And the high-level language is what we write. It's pretty human readable. Areas means 5 multiplied by 5, and that is pi, 3.1415 something. This is all the C, C++, Java, Python are all high-level languages. And of course, there are some other popular languages like ADA, Basic, C, C++, C#. But usually, we only need to learn C, C++, Java, Python is enough. Unless you have some special interest, like if you are interested in programming games, and they use the C# pretty often. And then we will get some notions of the compiling things, interpreting things. Like a computer written in a high-level language is called a source program or source code. In last lectures, we create our source code by the following steps. First, we create a text document, right? And then we change the document's extensions to Java. After we change it, we can see that in our Explorer, the document type has changed to Java source code. And at that time, you will have a source program. That is a source code. And for interpreting the source code, this is the Python way. Like you use the interpreter, reads one statement from the source code and translate it to the machine code or visual machine code and then execute it right away, as shown in the following figures. This one, you have such instructions, use statement in your source file, and the interpreters read it and immediately output it. Here we don't have compile thing. We don't using the JVM. Is because this is the Python way, but it is also correct. Just because different languages use different ways to translate their source code to the machine. And this is the compiling source code. This is the Java and the C++ way. And you have the high-level language source file, right? You have the statement, and you use a compiler to translate it into the machine code. And then you use the executor, not you, the JVM or the GNN, G++ will then translate it into a machine code that the the computer can read. Then they process it and get output. Two different ways. And this is a whole view of the operating systems. For the whole operating systems like our Windows 10 and Windows 11, and this is actually all the Windows systems is a program. Everything is a program that it manages the controls of the computer's activities. Like the popular operating systems for the general purpose is Microsoft or Windows. That's what we use, Mac and Linux. Actually, Mac is a certain kind of Linux, but just because Mac has their own way to run it. However, Linux is open sourced, and there are a lot of different dialect and different categories like of Linux, like Ubuntu, Red Hat, or CentOS. And you will get some knowledges of it if you take the C or C++ course. It's pretty useful. And in the operating systems, you will have some application programs like the Chrome. We say a web browser or word processor, that is the doc, Word or the slides. We use the PPT. They cannot run unless the operating system is installed and running on the computer. And then that is for the first lectures, but we still have, since last lectures, we only installed the documents. So for this course, we have to include something more. And I will start for the second slides. We will not have break. And if you want break, you can just leave and take a break by yourself and come back. I don't think today's class will too difficult for you. So just take away that you feel comfortable to participate. It's fine. But for the lab sessions, it's not. But for today, it's okay. And actually, for the second chapters, we still have to learn something more. And today I will going to introduce something more specifically to writing some other Java instructions. And here I will introduce what is a variable and how can we declare it and use it. A variable that is a named containers that hold a specific piece of data. Okay, what that? Like in our code, we say int x, and the x is a variable. And this is the way how we declare the variables. Why we should declare the variables is because we have to tell the program what we should have. For example, in our code, we should have a variable named x, and this is its type. Int, double, char, string is the variable type, and the x, radius, as is the variable names itself. And after we declare the variables, we have to use it, right? And how can we use it? And before we use it, what should we do? And then before we use variables, we should assign some values to it, like meaningful values, like for the int type x. Oh, I assigned 1 to the x. That means from now on, the x means the mathematical numbers, numerical numbers 1. And for the radius, we assign it to 1.0. And for the a, what is a? A is a char type, right? We just mentioned char. It's okay if you cannot remember it. Just have a notion that char is a type. A is a character variable. And so that we give it a value, we give a character to assign it, like A or B or C. For the characters we have to always come with the single quote. And for S is a string. That means it's a sentence. Here, string S. We declare a variable named S, and then we give it a value. The value is Java. Here, we use double quote. Or you can say that the string can be something like we wrote in the last lectures. That is, oh, welcome to our Java class. Hello world. That is a sentence. Or also we say it is a string. We assign such a thing to the variables after we assign the statements, and then we can use it. Okay, here is a one-step way to declaring and initializing everything in one time. First, you declare the type. It is int. And then you give a name to a variable that is x. After that, you assign a value to it that is 1. And for the double D and string S, it is the same thing. And there are some conventions of the variable names. It is pretty important. You have to remember it. Because in our quiz, in our assignments, and in our maybe in our exams, we will include some questions. Like I will have you to identify what is a valid variable names, what is not. Okay, let's go through one by one. A variable name is a sequence of characters that consists of letters, digits, underscores, and dollar signs. A variable name must start with a letter, an underscore, or a dollar sign, and it cannot start with a digit. A variable name cannot be a reserved word. We just mentioned like public class, main, right? And some other things, static. Both of them are reserved words. You cannot use it because it is for some other purpose by the program. And I will post it after our lectures. And a variable names cannot be true, false, or null. Actually, both of these three are reserved words because they have some specific meanings. And a variable name can be of any length, but as short as you can, but the name should have specific meanings. Before I introduce this thing, let's try in our IntelliJ. You don't need to do that. You just watch me. It's fine. Let me show you a demo. Like I knew Java class, like name. Okay, remember when you create class, always start with capital words, okay? Name here, and then we declare something like int. This one is 1. Okay, and then we assign the value 1. This is correct. But what if we change the sequence? Like we start with 1. 1 is 1, right? 1 is 1. And then we assign the value 1 to it here. And you can see here is the output of the log. First, identifier expected, unexpected tokens. Everything is in the line 3. And cannot resolve symbol is 1. Okay, why the first here is discarded? I don't know. Identifier expected. Why it cannot identify? Okay, actually, I don't understand the output, but what I should know is that I cannot start declare a variable names begins with a number. If I remove it, oh, everything resumed correctly. And the output is just a warning that something is never used. So you have to remember all the conventions I mentioned in the slides. Otherwise, you will make mistakes. And I think that will be included in your W3 school certification exams. It's a pretty common knowledge. After that, I will introduce some numerical data types to you. For example, for those data types, byte, short, int, long, float, double, what you have to remember, I think you must memorize it, is the first column and the last column. You have to remember all the data types storage size. Like for byte, it is 8-bit sign. For short, it is 16-bit sign. It is signed. And for int, it is 32-bit sign. Okay, currently it is a little bit abstracting, so I will use a painter. I will use a painter. Let me get a shortcut of it to describe it. I have to get please wait a moment. I'm here. Paint. Where is my paint? I cannot show. Oh, here. Okay, here. Oh, it's too big, but it's okay. Oh, I have to. Oh, please wait a moment. I have to get another shortcut from the first slides so that you will know how the data is stored. Oh, I cannot. Oh, here. Okay, I will only using the first one or the second one. Take as an example. Here we say a byte is 8-bit sign, right? First, what is a 1 bit? 1 bit means a single address. This is 1 bit. 8-bit means that this a byte number, it will contains 1, 2, 3, 4, 5, 7, 8 spaces. Okay, let me indicate something meaningful. That means here to here is supposed to 8. For a byte, if we say 1, for the number 1, right? Decimal. Oh, sorry. For a decimal 1, for decimal one. If we write into the binary code, like 1010, it's supposed to be we always start from the right. The right indicates the lower bits. 1. And the binary of the decimal one is present like this. In the memory, and it will looks like please wait a moment. I have to remove the content of it. Oh, sorry. This is actually I made wrong. This is means not this is 8. That is, oh, sorry. I have to correct. This is not, this is 8. This is red thing is 8. It will contain 8. It contains 8 bits. That means it is this long. However, if you are declaring a short type of numbers, we also using the decimal binary number. If it is short, that means it is 16 bits signed, right? And in this case, we will have 8 more bits. And for those 8 more bits, that will be showing like this. And how the short type data is storing, and if one container can store 8 bits, for the 16 bits type numbers, in that case, we will use 2 containers. So we put, okay, where it cannot show. I can, sorry. For the first part here, we will store it in the here. And for the second half, we also store it, but they should be concatenate to each other. And for this one, I use orange. These 2 containers together, these 2 memory address together, also meaning this is a value, decimal value 1. However, this is 8 bits, 16 bits. 2 8 is 16 bits. That is the difference for the types and how they store in the memory. And why should you remember this one? It's because in the future, we have to learn something about typecasting. That means what if you declare a short type, however, you assign these short type numbers to a longer space variables. What's the behaviors of the memory will be there, and you have to discuss something or you have to extend something, and you will know at that time. But currently, you just need to remember the name and the storage size. It is a requirement. And then let's get back to the slides. Oh. And for the next, I will introduce something more easier to you. That is what we have done. We have print something to the terminal using the system output print line, hello world. And this get the computer to print something to the console, and the print ln, remember this is print line, and as a new line at the end. If we don't have the ln here, it will only print something, but will not generate a new line. Here, the print prints the line. That's the difference. And usually is used for debugging. And it can also use for some other purpose, but it depends on what you want. And there are some simple string operations, concatenation, use S plus. In the sort instructions, we can concatenate two string, like if we declare something and YY, right? And we can use plus to concatenate them together. I want to give you a show, but how about we don't have the break and I go through the next. Okay, I can only introduce these slides and we'll end of our session. Okay, I will introduce these slides. And we can use the length method to get the length of this output. So for these two, I will give you a demo and then we will conclude our course today. Okay, first, the simple single quote string operations. Let me get back here. Okay, let me write a new class to give you a demo. String demo. Okay, remember each time capitalize the first characters here, and everything always start from PSVM. And here we can declare a string. And then it will indicate us something, but it's fine. Means January. And we declare another string YY means we use double quote 2002. How can we concatenate them? And then we use the sort to try. Print line plus, let me get back to the slides. What is output? Plus YY. Okay, I will replace it. It seems that, okay. It seems that the code in the slides has some problems. I think it's because the Unicode problem. So I type it by myself. And then here is how can we concatenate two strings together. We can straightly using plus and plus. And what does it use for? Okay, this is a space. That means we include a space between the between the MM variable and the YY variable. Let's see what is the output. January 2022. What if I don't have this? Okay, I will write a new line. Each time if you don't want this output, you can comment this using double slash, right? We just learned today, and we remove it. So currently, and I will have only my variable mm and my variable yy. What is the output? Let's see. See, and then no space there. And what if, let's try a new thing. If I don't use the ln, right? We remove this and see. Okay? See. That's wrong. And as you will see that the January and the year, they are concatenate together. However, since this print, they do not contain an ln. We say line. We do not contain a line there. So it will not automatically generate a new line. And immediately it will concatenate another that is January, and a space corresponding to here. We just input the double quote with a space, and then a YY. That is for this demo. And let me see the next slides. What is the, and for the length, okay? I will use the course sample, and I will comment. I will use a multiple line comment here. As we have introduced, if you're using a slash and dash, slash and star, and all the content in between will be commented and will not be executed. And this is the code from our slides to indicate how can we count the length of the string. But there are some errors. It seems that the slides use different encodings in writing their code, so there are some mistakes there, but we can correct it by ourselves. In the slides, we have declare a string, the name is Donut Duck, and then we declare a variable that is the name length. It is an integer type. And we use the name, we just declared this is the variable name. And we use the dot length, that means a method to count the name's length. Then we can output the length is okay plus length. And this is we just introduced. How can we concatenate two things together, right? And then let's see. And you will see that the output is the length is 11. That means this string counts for 11 characters. We can count that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 correctly. Okay, that is the course for today. And I will stay here. If you have any questions, you can come to me. And if you don't have questions, you can just leave. And I will also upload the code in the Brightspace. You just have keep an eye on the contents there. All right. Thank you for participating.
Thank you.
take
Good
attendance?
night.
Did you take attendance in the beginning? Because I
Oh,
was here
it's
after.
okay. It's okay. It's okay. I usually don't. I, I will assume everybody is coming. Okay. I don't
Okay.
want to make too much pressure to you because I know that some of you may be taking some part-time jobs or you may taking care of your children. Although the chair asked me to take the attendance, but it's fine because it's a programming course. As long as you practice after course or before the course, if you learn something, is enough. Attendance is not importance.
Okay. Thank you very much, Professor. Have a good
It's
night.
okay. You too. Bye bye.
Professor,
Yeah.
and we should do the coding you did today.
What?
The coding
Oh
when you
yeah.
was practice. Oh, okay, okay,
I will have the recording.
okay.
Yeah, you can review the recording, and I think it's better for you to implement the code by yourself. Although I will upload the code, but please try to write by yourself, okay?
But I don't find the recording the last class on Tuesday.
Our last class there's no code, but today I will.
Okay, okay, understood.
Yeah,
Okay.
yeah, yeah. Thank you.
Thank you. See you next
Bye.
month.
Bye.
Bye.